Okay, so grade 11s. This is just a quick video to explain how to do number 9. Several of you have asked me about it. This one's not going to be on the quiz, but I know that you want to know how to do it because you're good students, right? And you want to see how it works. So here's the deal. We set this one up, same as always. Okay. Now, a cannonball fires 500 meters downrange. So that's what they're saying delta x is 500 meters. Okay. So that's delta x. It says it's set at a 40-degree angle. So theta is 45 degrees, right there. Now it says at what velocity does the cannonball leave the angle? They're looking for v. Not vx, not v1y, but v, okay? Now what they don't tell you is delta dy is 0, but we would assume, if they don't mention a height, we can assume it's 0. So in other words, it starts on the ground, lands on the ground. All right, so now with that in mind, what I'm going to do is I'm going to use equation 3. Okay, so I'm going to start with, actually, you know what? Why don't I start with the x component? I'm going to write Vx equals delta dx over t. Okay, so that's 500 over t. Now, I don't know what the time is, so I'm just going to leave it like that. Now, for the vertical component, I'm going to write delta dy equals v1y t minus 4.9 t squared. I'm making up plus when I say that. And here's the deal. Okay, since up is positive there, I get that. Now I'm going to get 0 equals v1y t minus 4.9 t squared. Now I'm going to solve this for v1y. v1y will equal, okay, a t will cancel out, by the way, because delta d is 0. And v1y will equal 4.9 t when you do the math there and rearrange it. So I have two equations. I have Vx is 500 over t, and v1y is 4.9 t. Well, when I launched my object, the launch velocity is v. This is Vx. This one is v1y. Okay? And then this angle here is theta. Okay? So now the deal is I'm going to use SOHCAHTOA. So I'm going to use tan of theta equals v1y over vx, like that. Okay? So tan theta equals v1y over vx, because they do tell me theta. So tan of 45 will equal 4.9 t divided by 500 over t. See what I did there? I substituted these things in here. Now, tan of 45 is just 1. Here, how do I divide by a fraction? Well, I multiply by the reciprocal. So I end up getting 4.9 t squared over 500. Solve that for t. Okay, so I get 500 by cross multiplying. Okay, equals 4.9 t squared. All right, so now I'll just go 500 divided by 4.9 is 102. Take the square root. I get 10.1 seconds. So t equals 10.1 seconds. Now, I'm just going to pick one of my things. And I'm going to say, okay, well, therefore, v1y will equal 4.9 t. So I'm going to take that and multiply it out. Oops, pardon me. Let me get rid of that annoying thing. Okay, so I'm just going to times that by 4.9. I get 49.5. So this is 49.5 meters per second. And now, finally, I'm going to use my y component. I'm going to say v1y equals v sine of 45. So I know this is 49.5 on this side equals v sine 45. Just divide both sides by the sine of 45. That cancels. And I just got my answer here. I'm going to divide it by 45 sine. And I get 70. So the answer is v equals 70 meters per second. There you go. Okay, and that is how you do question 9 on the worksheet. That was not on your test though, so chillax, guys. Okay, and we'll talk to you soon.